Imagine taking the world's largest, most barren desert and engineering it into a massive, thriving, carbon-capturing forest. The modern Sahara covers over 9 million square kilometers. It is an environment defined by extreme heat and sparse vegetation, where a process called desertification is steadily degrading the land and threatening the livelihoods of millions of people living along its borders. To halt this creeping sand, policymakers have proposed massive artificial afforestation projects. By pumping desalinated seawater inland and planting vast tracts of drought-resistant trees, we could theoretically sequester billions of tons of carbon dioxide while creating millions of new green jobs across the continent. And we know a Green Sahara is possible because it has happened before. Look at this ancient rock art found in the middle of the desert. It depicts an elephant. Roughly 10,000 years ago, during the African Humid Period, natural shifts in the Earth's orbit transformed this arid landscape into a lush savanna, rich with wildlife and megalakes. Recreating that fertile aura today using modern geoengineering seems like a perfect solution. It offers a way to solve regional desertification and pull carbon from the sky all at once. But the Earth is governed by global teleconnections. Our planet is a highly synchronized biological system rather than a collection of isolated zones, and you cannot change the weather in one region without triggering reactions elsewhere. Calculations that only consider the African continent miss the massive downstream atmospheric reactions that would follow such a large-scale intervention. To see what happens when you green North Africa, we must follow the trade winds 3,000 miles west across the Atlantic Ocean. Because solving Africa's climate crisis in a vacuum will inadvertently trigger an ecological collapse on an entirely different continent. This is the Amazon basin. With its dense canopy and massive river systems, it is the most biologically productive terrestrial biome on the planet. But underneath this canopy, the dirt itself is surprisingly dead. Despite the intense growth above ground, the Amazon soil is some of the oldest and most nutrient-poor on Earth. The culprit is the climate itself. Millennia of heavy, daily tropical rain actively leaches the topsoil. Water rapidly dissolves essential life-building minerals and washes them deep underground, entirely out of reach of the root systems. The most critical limiting factor is phosphorus, the primary constraint on the forest's growth. Because rain washes it away instantly, the forest relies entirely on an external resupply to keep its biological engine running. The world's richest forest exists on the world's poorest soil. It is effectively on a long-distance, invisible life support system. That life support originates in a specific, hyper-arid pocket of the Sahara Desert known as the El Juf region. Every year, powerful trade winds sweep across this barren landscape, acting like an atmospheric conveyor belt. They lift hundreds of millions of tons of dry, mineral-rich dust high into the atmosphere. Look at this satellite view from above the Atlantic. That massive brown cloud is a Saharan dust plume. Roughly 27.7 million tons of this dust land on the Amazon annually. Woven into those particles is exactly 22,000 tons of phosphorus, the precise amount required to replace what the rain washes away. Now, let's run the afforestation simulation. We plant millions of trees in North Africa. Their roots grip the sand, and the new canopy slows surface winds. The dust stops rising. Almost immediately, the transatlantic dust highway shuts down. Cut off from its phosphorus supply, the Amazon starves. Plant growth stunts, the forest canopy degrades, and the region's ability to absorb global carbon emissions collapses. Out in the ocean, a second starvation event begins. Saharan dust carries soluble iron, which is the primary fertilizer for phytoplankton. Without it, the microscopic organisms that form the base of the entire marine food web begin to die off. This dust also acts as a hurricane shield by filling the atmosphere with dry air that suppresses storm development. Removing that dust allows the tropical Atlantic to warm and reduces wind shear, which simulations suggest would cause Atlantic tropical cyclones to surge in frequency and intensity by 27%. The geoengineered fix to save Africa's climate inadvertently destroys the foundational nutrient cycles and weather stability of the entire Western Hemisphere. From this height, we can see the planetary metabolism in action. Earth functions as a single, highly synchronized biological organism. We often view the Sahara Desert as a barren void in need of repair, But that perspective ignores its active role in the Earth's system. The Sahara is a vital, functioning organ. It is tirelessly pumping essential minerals through the atmospheric bloodstream to feed ecosystems thousands of miles away. Any future geoengineering project must be evaluated through this lens. Massive interventions like Saharan afforestation cannot be treated as isolated experiments or calculated using only local data. The invisible dust highway blowing across the ocean is proof that to save the Earth, we must first respect that every desert, forest, and ocean is inextricably tethered together.